Hi, this video is on lesson 5.3 from Envision, and it is on solving equations using the distributive property. So how does the distributive property help you solve equations? So let's get started. So we're going to look at this first word problem that's in your textbook. It's example number 1. And as usual in your textbook, it's already worked out for you. So if you're going to follow along with us in the video, I would advise either getting a Post-it note and sticking it over the work that's in your book, or just maybe laying a piece of paper over top of the work and then writing this down as we go, because it'll be more meaningful for you if you write it down as you follow along. So here's a situation with Chen and his graphic novels. Yes, each one of the graphic novels in Chen's collection increased in value by $3.50 in the last few years. I'm going to read this correctly. If each graphic novel has the same value, what was the original value of one graphic novel? So in this problem, we're going to look and see, what's the unknown? What's the thing that we don't know? I'm going to start there. And the second thing I'm going to look for is there some sort of total that I'm going to be combining all these things up to be able to equal the total. Because if I'm going to write an equation, then I'm going to most likely have a value on one side, and then on the other side, I'm going to have an expression. So let's see if I can find those things. So let's start with, what is the unknown? What don't we know? So I can find the unknown. Usually, if they give me a question mark, I should be able to work my way back to the question mark and find the question word. It says, what was the original value of one graphic novel? So I'm trying to find the value of one graphic novel. So I'm going to make that N for a novel. And then N is my variable, and that is the amount of money per novel, or really comic book, right? So dollars per novel. And that's the original amount, not the current amount, but the original amount. And I say that because they've increased in value. So they're more expensive now than they were when he originally bought them. The current value, how much it's really worth here, is now $75. And that's $75 for 10 novels, okay? There's 10 novels, is $75. Not just one. Okay, so how do I set this up? Well, like we said before, is there a total? Well, there's a total amount, and the total amount that it's worth is $75. So that means if you take all 10 of those graphic novels and you add them up, then they would be worth a total amount of $75. So, well, how much is each one? It tells us that it's increased in value by $3.50. So that means the price of each one is what I'm trying to find. The original price has increased. So how do I show that as an expression? So it's what it used to cost and $3.50 more, because that's the increase. Increase means it's gotten more expensive. That would be how much each one has increased. So that means this top one, the value of this top novel here is N plus $3.50. The next one, Tiger Man, is what it was, which is N plus $3.50 more. And I could do that with all of them. So I would have to add each one. I would have to add N plus $3.50 plus N plus $3.50 and N plus $3.50 and N plus $3.50. But how many sets of those do I have? So since each one is this amount, that's really 10 of the same amount. So I'm going to take the amount of one, which is N plus $3.50, and I'm going to multiply that by 10, because all 10 of them are the same price or value. When I do that, when I add the entire collection together or multiply the amount by 10, the total value is $75. So now I've written the equation. And what you might notice about this equation is that it's slightly different than the ones we did before because this has parentheses in it. That's going to add an additional step to solving, because when we have our equation and now we're going to solve it, when you have an equation with parentheses, then the first thing you have to do is use the distributive property. And that means I'm going to multiply the number on the outside by everything on the inside the parentheses. So 10 times n and 10 times 350. So 10 times n is 10n. 10 times $3.50 is $35. And between these two values is an addition symbol, so that goes here. So what that means is each of those graphic novels originally cost n dollars. There's 10 of them, so that's 10 times n. Now, if each of them have increased by $3.50, that's a total increase of $35, because that's $3.50 for each 10 of them. So that would be $3.50 times 10. So that's a total increase of $35. When you include all the original prices and the total increase, that equals $75. So that's what this equation means. So now that I've used the distributive property, this is a very simple two-step equation to solve, and then I would solve it. I would subtract the constant first, since I'm adding. That would give me 10 times n equals $40. And then I would divide both sides by 10, because I'm multiplying n times 10, and that would give me n is 4. So what does n mean? Well, I go back to the beginning, and n was the original price per novel. So that's 4 is $4 per graphic novel. So that means originally they were each $4. So let me see if this makes sense, my problem. So if they originally each cost $4, so this top one here would have been, change my pen here. So if this was $4, now it's worth $3.50 more. That means that each of these novels are now worth $7.50 each. So if they're each $7.50 and there's 10 of them, if I add $7.50 10 times, do I get $75? And yes, I do. So this answer makes sense. So now if you choose to look at the answer from your book for example number 1, you can see how they solved it and set it up and see if there's any difference and if you understand the method that we used to solve the first example. Now we're going to move on to the try it, which is at the bottom of the page. And this is a chance for you to try to write your own equation, and then you can check your answer. But let me read it to you first, and then I'll tell you to pause. A collector has a box of 32 figurines. The value of each figurine increased by $2.32 over the past year. The box of figurines is now worth $114.24. What was the original cost X of one figurine? Now, when we typically speak and say sentences, we don't typically just say a letter at some point in the middle of the sentence. So when they just say a letter, like, what was the original cost X of one figurine? They're not asking somebody named X a question. Like, they're telling you that X is the variable. And here X is the variable, and X is going to be represent the cost of one figurine. So what is the unknown? What am I trying to find? That's where we should start. That X is the dollars per figurine. And a figurine is kind of like, it could be anything really. Almost like an action figure, or possibly something that's like ceramic, or something that you would look at. So what is the cost per figurine? And when you're writing this equation for yourself, you want to keep in mind that, there's going to there's blanks in the workbook, you can ignore them. You can just go ahead and cross them out. You're just going to use the blank space in your workbook. So there's probably some sort of total in this word problem. There's some sort of total. And over here on the other side should be the expression that shows, you combining all of the information together to create that total. So why don't you read the problem again, pause the video, and try to write the equation on your own. And then you can resume the video and see how you did. Okay, so let's see if you have the same thing that I have. So to write the expression, in this case, the expression is that the original value is X, and now that is increased by $2.32. That's for each figurine. Since there are 32 figurines, first of all, this right here represents this right here is the new value. It's the original value plus the increase is the new value. So that means all 32 of them cost the same amount or have the same value. So that's 32 times this new value equals the total net worth, which is $114.24. So now I have an equation, and so you can check and see if your equation matches mine. And now that we have the equation, we can solve it. So when we solve this equation, step one, when you have the distributive property, we have a number on the outside of parentheses, is you are going to multiply everything inside the parentheses by that number. So 32 times x is 32x plus 32 times $2.32 is $74.24. And then that equals $114.24. So now to solve this equation, I am going to subtract the constant from both sides. So you can go ahead and solve it in your book. And then if you want to listen or periodically look up and see if yours matches, when I subtract $74.24 from both sides, then this one goes away, and I'm left with 32x over here. And when I subtract these, I get $40. So 32 times x equals 40. So I'm going to divide both sides by 32. And I get that x equals $1.25 or 1.25. And I've interpreted it as $1.25 because when I look up here, remember x equals the dollars per figurine. So that means that it's originally cost $1.25 per figurine. So there you go. How did you do? Okay? All right, let's look at another word problem example. So example number 3, I skipped over 2. I'll come back to it, but example number 3 is worked out for you. So again, you want to cover that up with a Post-it note or possibly a piece of paper as we look at example number 3 and write out our steps. A cheerleading squad received 1/4 of the total sales of foam fingers and pom-poms at a pep rally. The squad received a total of $136.75. What was the value of the pom-pom sales? P. So what is my unknown? What am I trying to find? So to find that, I'm going to look for the question mark, if I have one, I do, and work my way back. What was the value of the pom-pom sales? P. So they're selling foam fingers and pom-poms at the pep rally. So let's think about this. Is there a total amount? Yes, there's a total amount. So the total amount of sales is, I have this here. $258 in sales for foam fingers. But that's not the total. The total would be here, a total of $136.75. How can the total be less than how much they sold the foam fingers? Well, if I'm looking at this, it says the squad received a total. Okay. Well, why are they getting less than how much they're selling the foam fingers for? Then I'm not even counting the pom-poms. If I look back at earlier, it said the cheerleading squad received 1/4 of the total sales. So they're only going to get 1/4 of the total sales. Okay. These two things added together, that's going to make sales. But they don't get all of those. They only get 1/4 of those sales. 1/4 of it means I'm multiplying it by 1/4. So now that I know this in words, let's fill this out. So they're going to get 1/4 of the sales, and that's the sales from the foam fingers, which we know is this amount, plus, and they also get sales from the pom-poms, which is P. The total amount they received was $136.75. So there's your equation. Now, if I'm going to solve this equation, the first thing I need to do is distribute the 1/4. So 1/4 times this number and 1/4 times this number. So 1/4 times 258 is $64.50 plus 1/4 times the pom-poms equals $136.75. That means they made $64.50 off of the foam fingers, and they made some off of the pom-poms. And we're going to figure out how much they made off of the pom-poms, and that's going to help us figure out how much were the actual sales of the pom-poms, since they only made 1/4 of it. So to solve this now, I'm going to subtract the constant from both sides. Now, some of you might have the 1/4 P first and the plus 64.50 second. That's okay, because either way, I'm going to subtract the 64.50 first, because I subtract away the constant first. Here, I'll draw this line down for you to help you see. That makes this go away, and I have 1/4 times P equals 72.25. Yeah. And then to solve this, I could either just divide both sides by 1/4. That would work, because I can just divide by what I'm multiplying by. I could also multiply it by the reciprocal. So I'm going to write that down. I'm going to multiply 72.25. I'm going to multiply that by 4. And I get that P is 289. So what's 208? Is that 289 pom-poms, 289 foam fingers? No. If I go back to the beginning, P is the dollars in pom-pom sales. That means that they sold $289 worth of pom-poms. They didn't get to keep all that. They only got to keep 1/4 of that. But that's okay. That's how much they sold. So that is the answer. And you can look how they solved it and see if you have any questions about number 3. So I have this non-word problem, and it's abstract. So I don't know what S represents. I'm just going to find out what S equals. To solve this equation, the first thing I need to do is use the distributive property. That means I'm going to multiply all the numbers inside the parentheses by the -5 on the outside. I have to be very careful, because on the outside is a -5. So -5 times S is -5S. Plus -5 times 30 is -150 equals -17. So when I go to solve this, I have to be careful, because I'm adding a negative. So to get rid of adding a negative, if I can subtract a negative 150 from both sides. So if you understand that, you should. But another way to do it is, since this is a negative 150, to get to 0, because I want to get rid of that term, I would add 150 to both sides. And then, that's a 150. So 150 and then plus negative 17, or yeah, we'll do it that way. Then that would equal 133. Which all equals negative 5s. So to solve this, I'm going to divide both sides by negative 5, because whatever's in front of the number, that's exactly what I divide by. So negative 5. So this would equal negative 26. .6. So S equals negative 26.6. Okay, so that's what I think. Now, since I don't have a word problem where I can go back and check it logically, I need to use RSS to check. So I'm going to use RSS. So I'm going to rewrite the original problem before I did anything to it that it did check. So we solved it correctly. And we don't know what it's about, so we don't have any way to make context. We're not going to have any labels or anything. So those are the 3 examples from your book, and you're going to see that there are more problems in the Try It where you have to solve equations with parentheses, and the trickiest part is when you have this negative on the outside. So I would like to just look at, I'd like you to do the Try It. I'd like you to look at one problem together. I'd like to do letter C. So I'm going to use the distributive property first and do that. That would give me negative 4 times P is negative 4P. And I'm going to leave a lot of space between my numbers. Watch this. Negative 4 times 212 is negative 848. Between these numbers already is subtraction. So I'm going to leave that as subtraction. Okay, so for now I'm going to leave that as subtracting a negative. That equals 44. When I see the double signs, I have negative 4P, keep, change, flip, and that equals 44. So now I solve this equation. P equals, so if I put that in the calculator, negative 804 divided by negative 4, I'm going to get 201. Positive 201 because both of them are negative. So there I go. Now when I go to check this and I RSS it, then I have to make sure that I rewrite it exactly as it was. So negative 4, and then in parentheses was the P minus 212 equals 44. Yeah, but you can just use a calculator, type negative 4, and then 201 minus 212, enter, and I get 44. So 44 equals 44, check. You may try the other try-its just to see how you do on your own. Thanks for watching.